Welcome back to part 2 for topic 9 for Algebra 2 on parent functions. In this video, we're going to focus on transformations and how that can apply to our parent functions. So first, when we're dealing with parent functions and transformations, we're going to visually see this on a graph as well as represented in our equation here algebraically. So that's why I have both represented. In my mind, the easiest thing to start with is our vertical shifts, either up or down. So if we think about our transformations, If we think about our transformations, I have the parent function marked in red and then the transformation marked in blue. So if we look at our parent function here, let's match this. If we look at our parent function here, our parent function is the absolute value function. So the absolute value of x. Now, in order to get from my red function to my blue function, I'm going up 2 units. And you can literally see it here in our graph. So up 2 units. Whenever you want a vertical shift, you're going to take your function, and then on the outside of it, add units. So our k is like our constant that we're adding here. Similarly, if we want to have a vertical shift down, here our parent function is x, so a linear parent function. And we're going down 1 unit. So from our parent function of, let's say, f of x, we are now subtracting k. Pretty self-explanatory. Now, in addition to going up and down, we can also go left to right. So here we have a cubic parent function. Because it's something to the third power. See, we see that third power right there? So that's my red function on my graph. Now we're shifting to the left here, we can see. We count over 1, 2, 3, 4. So we are shifting left 4 units. But notice how in my equation it's x plus 4. This is because we are always having x minus our value. So in this case, this is the same thing as x equals x minus a negative 4 cubed. So that's where we get our positive from, a negative times a negative. So if we want to shift left, we're really going to take our value and add it to x. Or we're subtracting the negative value from x. So if we have our 2 negatives, it makes a positive. If we want to shift right, here we have a parent function that's a square root function. And if we're shifting right, here we're going right 1, 2, 3, 4, 5, 6. So we're shifting right 6 units. We're also having it in our function. So we have f of x, but in this time it's minus h. So if we want to go to the right, we are subtracting. Because what we're doing here, this is really y equals the square root of x minus a positive 6. So we're subtracting a positive number. Now, there are other ways we can combine these if we want to, oops, that looks a little odd. There we go. If we want to combine our vertical shifts and our horizontal shifts. So for example, we could have something like f of x, oh, that looks wonky. Let's try that again. F of x equals x plus 3 squared minus 2. So here we are shifting left because we're subtracting a negative 3, and we're going down 2 units. So I like to think with the vertical, it kind of matches intuitively what you would think. You were adding to go up and subtracting to go down, But with horizontal, it's the opposite of what you think. You see a positive sign when you're actually going left, and a negative sign inside when you're going right. Now we can, oops, there's a duplicate there. Never mind, Slake. Okay, we can also deal with reflections. So reflections, we can reflect over the x-axis as well as over the y-axis. So a reflection on the x-axis is made by multiplying the parent function by a negative. The graph then, if we can see our parent function here, let's just note that, our parent function here is x squared. And instead what we're doing is we are flipping it upside down. So we're going into the upside down. Think of like Stranger Things. So the graph is upside down. Think about if you were like walking by, I don't know, the ocean or water and you kind of see the reflection. It's like over the x-axis there, so it's dropped into the water. Algebraically, what we would do is we would take our function and on the outside, it's multiplied by a negative. That's how it reflects over the x-axis. Now we can also reflect over the y-axis. So a reflection on the y-axis is made by plugging in, instead of x, we're going to plug in negative x wherever we see an x. So the graph basically swaps left and right values. We can see it here on our graph. So here we have a function and it's raised to the 5th power. So our parent function is in red, and see how it's literally swapping left and right. So we're reflecting over this y-axis here. So what we're doing with our function is instead of f of x, we're basically plugging in negative x every time we see an x. However, I want you to note that this only will appear with odd functions. So for example, we have an odd function here. It's an odd power. So power of 1, 3, 5, 7, etc., etc. Only with those exponents. Because if we think about it, if we have even exponents, if we take a negative number and we square it, or we raise it to the 4th power, anytime we have an even number of negatives, when we multiply them together, we get positive. So we would actually not see a reflection across the y-axis when we're dealing with those even functions there. Now, 2 other transformations that we can do. A stretch is made on the parent function by multiplying the parent function by a number that is bigger than 1. And these values are always positive. So that's why we have the absolute value there. So here our parent function is x, and we are stretching by a factor of 2. We can see this because a stretch is also referred to as a narrowing of the graph because the function gets closer to the y-axis. What I like to think about it, we don't always deal with lines, but it almost looks like our graph gets steeper. Because we have that big number multiplied in front. Here we have that 2. Now, on the other side, we can also deal with a shrink. Sometimes it's compression, called compression. So here we also have a parent function of x, but here we are shrinking or compressing by a factor of 1/4. So here we are dealing sorry, the bell. Here we are dealing by, here we are multiplying by a fraction, but the fraction has to be between 0 and 1. So oftentimes students see the number maybe like 3/2, and they're like, oh, it's shrinking because it's a fraction. But 3/2 is actually greater than 1. So we want a fraction that's in between 0 and 1. A shrink, or compression, is also referred to as a widening of the graph because the function gets closer to the x-axis. Sometimes people think that it gets flatter, because as we can see here, it's getting closer and closer and closer to our x-axis. And those are all the transformations. Thank you for watching part 2 of topic 9 for Algebra 2 on parent functions and transformations.